Hello, welcome back to BLENDERSUSHI live noding. In this video, I will further explore the idea of controlling the chaos using functions. In the previous video, I kind of ran through all of things that I could think of that's in relation to functions, whether it's to generate a procedural texture, or perhaps I have shown you already that you can use things like wiggle, which is actually noise functions to animate objects. And today I'm gonna do something that's a little bit simpler, where we're just gonna be using the spatial list mask and then play around with the components of a mesh, which is either points or edges or faces, in kind of in relation to functions, whether it's a random or noise or other kind of pattern, number pattern. Okay, so let's start with nothing. Let's hide the camera and the light. Let's go to compositing and just turn on the workshop. And I'll just gonna start with a grid or plane, because plane is gonna create grid. Just gonna create view draw and plug that in, increase the number, and we have our grid or our plane. File, save as. This is gonna be spatial function list masking. Alright, so let's have a look. Maybe we have 10 by 10, so 3, 4, 5, 6, 7, 8, 9, 10. So this is 81 polygons. What are we gonna do with that? So we're gonna use list masking. So there's a list mask out and list mask join. This is the list mask, is the one we're gonna use. There's also mask vertices node. So which one to use is really totally up to you. I believe both of them have a advantage over the other, but which one's easier, it really depends. Probably list mask out is the more recent node, because this has like the index true, index false, and then other options. This one doesn't have, and I believe list mask will work with any vertices or edges or polygon, so whichever you prefer. Let's try mask vertices, because I haven't used much of this guy, mask vertices. So what will it do? Let's just give it a try. Vertices goes into vertices, polygon or edge goes into this guy. So either edges or polygon. We can start with edges, and let's see the output. So yeah, we're getting the edges, but it looks like it's only picking one of the edges. Let's try a polygon. With polygon, we are not getting anything, which is quite interesting. Let's try plug in the. Let's try this guy. Usually with a masking, we only usually mask one of the data, but this especially masks the vertices, while with list mask, with this guy, oftentimes I just plug in the vertices directly into the final node, while the edges and polygon can be masked. So maybe that's why. I'm gonna show you if I plug in the edge and then plug this guy into that guy, and perhaps just turn on the level list. I'm getting every other edges. It's more clear if I plug in the polygon. See, I'm getting like a checker pattern because it's selecting every other. Currently the mask is like 0, so it's probably by default it's giving this 0 1 0 1 kind of pattern, so it's selecting every others. Try again with edges, and then yeah, increasing or decreasing the edges will give you that kind of pattern. But of course we want to have more control with the mask using functions into the mask. So let's go back to mask vertices. Yeah, this is slightly weird that I'm not getting anything, but I think maybe I should plug in something into the mask. Let's try random, not random vector, but random number. Let's save, and for the vertices, how many number of randoms? Normally the same number of the original vertices. So get list length, plug in vertices in data, and then we have now the total number of the vertices, plug in into the count, and with fewer tags we can check the data, and the data should be random numbers between 0 and 1, and we can remap that, and we should be getting new value. We want the value between 0 and 2, but we're gonna floor it. So currently it's see, we have random value between 0 and 2, but if we use math floor, we're gonna get a random value between 0 and 1, and it's gonna be a true and false data boolean for our mask. So that's I will do that quite often from now. Stretch of no data error, maybe it's just a bug. There you go, 110, whichever. Now let's plug this in to the mask, and what do we get? Oh, alright, I should be plugging this one into the mask. Okay, so now we're getting something. Let me tidy up a little bit. Okay, we can randomize the seed, and of course we're gonna have a, so we are kind of masking, randomly masking the vertices. I think in this case we can have more, or we can randomize further. By adjusting this number we can actually kind of control the probability of the random number. Okay, that's the seed. You know the drill. I think separate actually give an interesting result. Interesting. Yeah, by using this, so you get like a pattern already then, and it's quite complex looking, even though the setup is really quite simple. And if I zoom out, you can see it's kind of random. There is no pattern or whatsoever. but that's kind of nice as well to have. I'll back it out just to keep that, put that aside. So that's with random, and we can kind of see the randomness, you know, and it's kind of useful that way. And if you want to use something like, instead of random, let's use noise. Let's do that. We can use a noise function, vector noise. So vector noise comes in two flavors, scalar or vector. So which ones to use? Probably in this case is the scalar, because for our mask, that's we only need a like a scalar, because here the mask is true or false, and we need just a single number instead of 3, so we just need to use a vector noise. But the input is the vertices. Yeah. So let's try with the noise. Let's what are we getting with the noise? Let's have a look. The noise give us the value between -1 and 1. Actually, some noise give us like -7. That's probably a mistake. And sometimes we get a big number as well, which is interesting. But anyhow, we get the noise, and then we can remap the noise similar to what we did with the random. This is random. Now we have the noise. Just imagine the noise between -1 and 1 and then our new max and min should be between 0 and 2. And again, we're gonna floor the value, so it goes into a value between either 0 or 1, either true or either false or true. Let's plug that in. Now we actually can see the noise right here. And what else can we do to control the noise? You can probably answer that. We either offset the noise in X or Y or Z, or we can also scale the noise. So it's a similar thing to what you often do using texture in cycles or for displacement modifier. So that's the basic stuff. That's the basic idea. So vector math, if we use add or sub, we're gonna use add. We can then offset the noise. Let's do that real quick. Vector in, plug that in. So if I'm moving it in X directions, you can see the noise is moving to the left or to the right, so that's the noise moving. Or Y directions, that's also nice. You can move the noise in any way you like. If I zoom out like, you can really see the noise. Even if I increase the number like 80 and 40, see that's a noise pattern, almost like a cloud. And we can of course offset it in X and Y, and with the Z it's kind of almost like zooming in through the cloud, which is kind of cool looking at it this way. Let's maybe reduce the number. So we can also scale the vector to kind of zooming in and zooming out in the texture. So use vector math once again, and here we are using the multiply scalar. There are other math functions that you can use to control the noise. Just give it a try. Float, let me try. By default is 1. I can increase it so I have like smaller noise. If the noise really detailed, we start to get something that's more like random. Noise in itself is kind of like random, but it has smooth interpolations applied. So we have like smooth value because the value is closer to each other and they're related, while with random they're not really related. So we can zoom in or zoom out, things like that. Even things like that is really quite unusual. Normally you're not so easily get this kind of pattern for mesh. So I will kind of giving it kind of like this value. Yeah, so that's okay. That's cool. What else can we do with this? Mask vertices. Maybe if I plug in the polygon. Okay, yeah, with the polygon we are getting the poly, of course. What else can we do? So let's just bake that, for example. And this apparently works for any kind of mesh, not just the plane, but any kind of geometry that we have here. Line, plane, and gone. Box. Now let's try box. So the vertices should go in there. The edges and this guy's vertices also go in there, and then the polygon goes in there. What else? So we don't need that. This is for something else. Please mask out. Maybe probably more robust, but we're not gonna use that for now. So what are we getting? I'm increasing the number of subdivisions. Probably I give the value that's too big. Okay, it's almost looking like a cheese. Let's increase. Alright, so there you go. This is our kind of like a building that's kind of deconstructed, or I don't know what's the terminology. Broken down building, or maybe cheese. Let's reduce the number. Have to be careful with the number. Sometimes it's easy to give a big number and it might crash Blender or just taking too long. So yeah, we get that, and we can control the noise, bigger or smaller. And of course we can offset it. Yeah, so that's kind of nice. We can bake it out and use something like solidify, create a wall, and that can be maybe for a game, but even though that's super basic, I kind of interested in how we can procedurally maybe make a game level. The cube. It will also work with any kind of mesh here, even Suzanne, but it's gonna work on the points or edges. Let's try a cylinder actually. So box, we get the box, And this guy, let's put this guy to the side. Let's create a cylinder. Cylinder become one of my favorite because it's kind of nice. You can break it down into lines and circle. So box, plug in the vertex there. Okay, plug in the polygon there, and then vertices there. And so we have something like that. Is that what we want? Separate, not separate, cap off. The noise is not so obvious at the moment because it's a cylinder. If I increase the subdivisions, still not so useful yet. Maybe I will increase the number of subdivision. Now it's kind of more interesting looking. And if I turn it into a flat objects, we start to see something that might be a map. I don't know, maybe a map of a city. If the city is more like rounded like this, I think the city of the Paris is more like snail, but some city in the anime, Akira or something, have city that's kind of circular like this, I think, or maybe Star Wars, I can't remember. So increase subdivisions, increase the, or keep the height 0. Let's increase the noise a little bit or reduce it. Sometimes I have a feeling that this might not be the right way to do it. Not with the mask vertices. I think the other one actually doing it better. List mask. And if we actually break this guy and using UV connections, we might get a more interesting design or like a structure. Let's give it a try. Plug in the vertices there. So we have vertices and the data. Separate. Plug in the vertices in there and data. Not getting any result. This is maybe when the mask vertices is failing. Here I think we can use this guy. So we can keep the vertices, and with the edges we can plug it here, and then data if true, plug it into there, and we just need the mask, which is this guy. List level. This should actually work. Let me check real quick. UV connections, get in there. Okay, the number of the mask doesn't match the number of the data. So because I'm currently using the vertices, just use list length and get the edges, plug in there. Vector noise or random? I think I did it wrong. So vertices goes in there. That's UV connection. Maybe vertices goes in there and oh, okay, I see. Vertices should be outputted from the UV connections into there. Okay. And the data can go in there. Separate on and maybe I will work with poly. V or U. And let's see what should I do with the list mask. Get the data there. It's the mask. Yeah, I think I totally a little bit lost. I'm gonna save this and I'm gonna open the one I did earlier, list mask noise. It could just be a bug. I'm gonna kill Blender. File open. this guy. Okay, here I'm using cylinder as well, and I'm using the list mask, and let's see what I did here. It's much simpler. Cylinder, list length comes from the edges, and it goes to random. Apparently I'm using random. Of course, with random you can just plug into the count instead of I think with this kind of thing, eventually it's a good idea to just take a snapshot of the node setup and then reusing it. So that's one of the example. There's also another way to do it. I think in the other blend files I created like a kind of like a procedural city using these techniques. All we did is only masking, like masking out some polygon faces, and then just using math function to do that. Yeah, hopefully this can open. Might take a while. Okay, there we go. Good. File save as. So how did I create this? Similar to before, really. I don't know what's wrong with previous file. So we have vertices, and we have the UV connects, and we have the output of the vertices directly. I have the extrude face here, but we don't really need that. What is this guy doing? Okay, that's the pattern we are getting. Of course, we have the scale thing right here. Okay, I have a lot of polygon face over there. It's actually not this slow when I was doing it without recording. Okay, maybe I should delete. Let's delete this guy. We don't need that. Let's save it again. So cylinder, and we have list length. Plug into random. This is we are not using that, but we have UV connects, and then vertices plug into this guy. So this is gonna create the noise, map range, floor, mask. Let's delete this. So where did I do wrong? Slice. So slice is off. V or U directions. So that's a U or V. Okay, that's kind of nice. But we want it to be polygon. So cylinder, vertices goes in there, and then the edges. We're not using the edges even. The data just goes into that guy, and this the vertices created the mask, and then we have output. Okay, let's go back to our thingy. So slice is off. U or V polygon doesn't matter. Vertices goes in there. So this is where I went wrong. This level. Data if true or data if false. How odd. Okay, just data, and let's go back to this one. Vector cross product. I'm actually using cross product here instead of add. Cross product actually gives a better looking result, so that's one thing. So we have slice off, we have caps on, off, doesn't matter. Subdivisions, height 0. The edge we didn't get it from the data goes into the mask. Level of list 2. Not 1, 2. So this is list mask out. So I wonder, where did I go wrong? If those things are exactly the same. Let's create a snapshot. Let's get back to this guy. And let's open the screenshot. Yeah, I'm showing you how to do the troubleshooting if none of them working as we want it. Separate, height 0, subdivision doesn't matter. Next, U direction polygon. Okay, vertices goes into here. Cross product or add doesn't matter. It should actually work. And then we have the scalar thing going on. Multiply by scalar. And we have Blender or Perlin. This doesn't matter either. Noise. Clamp the value. Floor goes into the mask. This is list mask out. Level list. Data and vertices. Oh, I'm plugging the wrong thing. Yep, it's very joke. Sometimes I forgot. Yes, so let's increase the noise. This is when things get quite interesting. We don't need the cap off. It's funny that I keep getting the cap. Oh well, let's get back to this guy. Edges, spiderweb. This is spiderweb, okay. Polygon cup. So the cup view actually give a better looking result. That's exactly what I need. Increasing, decreasing the noise. Moving the vector. Let's try a new Perlin. I have a feeling that something is not quite right. Still. Level list. Edge goes into polygon. And that's not. Yeah, that's the data. Let's try baking it and then see. So as I bake it and I get this big face. Separate off, separate on, cap off. Maybe I'll try reducing the number of. Yeah, that's better. Yeah, I have a feeling that this setup might be a little bit flawed because the number of the data from here is not matching the data here. Maybe let's try length and then use stereoscope. (517) and 540. Maybe that's why. Maybe I just maybe in this case we really want to use the mask vertices. Polygon or edge, and the mask. And let's have a look. Now I'm increasing and decreasing the noise. UV connections, blah blah blah. Okay. Okay, data coming out from that. Okay, we don't need this guy. Can play around with this, but that's not what we want. Yeah, I have a feeling that perhaps that this setup, even though it's quick and you can get an interesting result right away, it's probably a little bit flawed in a way that we should actually just be masking the face. And not doing it like this. Radius top, radius bottom. Vertices. This looks kind of correct though. So that's the scale. I have a feeling that the other one works better. Let's try add. So cross product is actually better. And here I'm actually hiding the points, which is a good idea. Level is 2. Yeah, a little bit flawed, but then again, if the final result is what you kind of looking, then it shouldn't be much of a problem. Let's see, I think I have this guy, and then I think I give it. Here's another example. It's similar to before. That's another example of the result. And I also tried it with the tree. That's what I'm getting. So what did I do here? So I have these random points. Here everything is much simpler. I don't really use the edge. It's basically just the points. And remember the tree generator? I actually tried it here. I'm growing the tree based on these random points. Something for you to try if you wanna experiment a little bit. Yep. Super interesting. This tree thing is interesting. I don't know. Maybe we could push it further. But the random points is there. And let's have a look. It's based on a plane. And I did separate it. Let's reduce the number. 30 by 30. Connections U or V. Doesn't matter in this case. Probably I'm not using the edges. But if I plug in the edge, seems to be failing when I plug the edge. Okay, this is also another example. Turn on separate the edge. Okay, turn on the edge. That's what we got. Almost like the Braille Morse code or something. Yeah, hidden message. So that's interesting. If you want to know how this gets set, this is the node setup. Again, we have UV connections, and then we have the same drill. Scaling, offset. Maybe I can use cross product here. Cross product, give a different result. Just kind of playing around with the numbers, you know, cross product. Range, floor, mask vertices, viewer draw. This is the random, we don't need. So that's pretty much it. Let's try a small number. Can we see the pattern? Increase the number 50 by 50, 60 by 60. It's almost too random actually. Because I'm using cross product. That's why. Add. That's almost like a map or water. I tried this earlier and then I kind of really like this. This is almost like if you perhaps create multiply of a bunch of these, you might get something that's more interesting. In fact, I might do that. Slicer. Multiple. Let's see if I can do that real quick. Let's cut this. Start from nothing. Cross section. Okay, cross section. And let's have a box. We have box, and we have we're gonna cross section the box. Viewer draw. This is all improvised, guys. So hopefully this works. Edge polygon, fill the section, the matrix, cut matrix. Maybe we can just use the line. Matrix in, plug it in, location 10, 2, 1, 2, 3. Let's check the box. Okay, we actually have one cross section. But how about our cross section guy, our line? Where's the line? The line is going that way. Cut matrix. It's not liking it. Probably made a mistake. Matrix. Let's try matrix in. Cut matrix can be the vertices. Let's have a look. Okay, this can go up. Vector out, vector in, vertices x goes to z, y, z to the x, y to the y, vector goes in there. Yeah, that's actually what I want. Oh, I just realized something. Maybe we don't need to have this box stuff. We can just use the UV connection. Hide this. No. Cylinder. Separate. Caps off. Vertices goes in there. We got. Can save this for later. It's our cylinder. Hide. Caps. U. Slice off. Subdivision on. Slice. Maybe U direction and slice on. Let's try. Slice on and we get that. That's actually kind of what I want. Subdivision 2. This is 4. Okay, cool. That's what I want. And I need to subdivide this guy. That's why I was a little bit lost. That's kind of what I want, and I need to subdivide it. Can we use Fairchalk to do that? Can't think of that at the moment. Let's just increase this and then bake it, and let's cut this, hide this, and we have this. Let's subdivide it. Kind of wanting something that's more like a grid. Like, so just now I was a little bit lost when I was doing cross sections, but what I really want is more like grid, like something like that. And for each of that object, something that's different. But anyway, let's bring this guy in. Get selection, which is this guy. Get selection, and vertices can go in there, and turn on post modifier. And see what we got. This is almost like we don't need UV connection in that case. Let's plug this guy in there. There you go, that's what I want. You know what this looks like? It's almost like a volumetric kind of design. And we can still scale down and scale up our noise pattern. If I'm hiding the vertices, it's more clear. This is almost like the volumetric. If you're using Blender cycles and creating a volume density, and you're using noise, and that's kind of exactly what's happening here. Let's reduce the scale. Probably you don't need the edge. We need that. We can offset the noise. Yeah, I guess by now you probably understand the drill. Can use Voronoi. Cell noise actually give nice pattern sometimes. It's totally kind of messed up kind of design, but if we try again, let's have more subdivisions and then bake it and hide this, and we have that guy again. Subdivide it a couple of times and bring that in. Now we have another different kind of design. For now I give nothing. For now I crackle. Yeah, that's nice. Bake it, and there you go. That's what you got. Maybe solidify, give some thickness. Ambient occlusions. Yeah, so that's a kind of, it's pretty hard to get to this part, but then you can end up with something interesting like this. This is totally a little bit abstract and procedural. Maybe we can add a bevel a little bit, 0.1. Actually, let's solidify. This is the bevel. Solid bevel, maybe wireframe. More thickness at cap. There you go. Unlimited kind of design. It's kind of like a Babylon tower or something. Yeah, so there you go. The live nodding video for today. A lot of hiccups here and there, but that's really common. Basically, we are using noise functions, and we're kind of just masking part of objects and to generate something like this. It's not easy, perhaps, if you're doing it for the first time. Even I'm doing this for a few times and I still made mistakes because there are so many possibilities. Yeah, hopefully this video is useful for you. um, you can leave comments and yeah, let me know your suggestion or yeah, just any kind of feedbacks. I guess yeah, I'll see you on the next video, and